Okay, the first thing we're going to do is have a look at the proof of the cosine rule. Now we've already done the sine rule, but the problem with the sine rule is if I get a question that's something like this, I don't have those opposite pairs that allow me to solve. So in this problem, I haven't got a single pair that will allow me to use the sine rule to do any solving. So for these types of problems, I use the cosine rule. Now, to start proving the cosine rule, I start in the same way that I did with the sine rule, which is to break the diagram up into two right angle triangles. And I'm going to label this vertical part y and the horizontal part x. Now, if that's x down the bottom, then that makes the length from here to here, whatever a was, minus x. Okay, so we've added some extra variables in here. We've got x and y in here. Let's start by working with the left-hand side of this diagram. And I can work with this triangle here. And I've got b, x, and y. So using Pythagoras' rule, I can show that b squared is equal to x squared plus y squared. Okay, that's my first step. Now let's have a look at the triangle on the right hand side. Okay, for this one I've got y, c, and a minus x. So for this triangle, same thing. If I start with c squared, it is equal to y squared plus a minus x all squared. And by expanding that bracket, my equation becomes y squared plus a squared minus 2ax plus x squared, or if you prefer, let's make this x squared plus y squared plus a squared minus 2ax. Now my reason for rewriting that is I can see that I know that x squared plus y squared is equal to b squared. So my equation for c squared, I can use substitution and make that part b squared. And I'm starting to write my whole expression in terms of a's, b's, and c's, which is what I want because I added in this x and this y, and I don't want to use the parts that I added in. Okay, so we're nearly there now. We have everything except for this x over here in terms of a, b, and c. So let's go back to our first triangle and have a look at that x value. So this triangle here, I know that this angle is equal to c. So this angle is equal to c. And I want to try and find out a definition for x. So let's ignore y. This is the adjacent side. This is the hypotenuse. So I can say that cos of angle C is equal to x over b, and x is equal to b times cos of c degrees. Okay, now let's use substitution again. If we put this definition of x into my rule over here, then my final equation becomes c squared equals b squared plus a squared minus 2a times b cos c. Or slightly neater, a squared plus b squared minus 2ab cos of angle C. And hence we've got the cosine rule, which is a rule that has all a's, b's, and c's, and cosine. This rule can also be written slightly different. If I want, I can rearrange it to make it a squared is equal to b squared plus c squared minus 2bc cos of a, or b squared equals a squared plus c squared minus 2ac cos of angle B. So that's just rewriting it by rearranging the terms. That's it.